Hello, everyone, and welcome to today's SANS webcast, Cloud Security Automation, Monitoring and Operations. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Frank Kim, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Frank.
Great, thanks a lot, Carol. Welcome, everybody. Thanks a lot for joining this webcast. Let's go ahead and start with a quick introduction. As Carol mentioned, my name is Frank Kim. I have my own security consulting, CISO advisory practice. I've been teaching and writing classes with SANS for a long time. I was also the CISO at SANS for a little while, and currently the author and instructor of a few different classes, Management 512, Management 514, and the SEC 540 class, of which I'm a co-author along with Eric Johnson, Ben Allen, and Jim Bird. While we're going through the webcast or afterwards, if you want to contact me, my email is up here on the screen. We've got my Twitter handle in case you want to tweet any remarks at me during the webcast, which I won't be able to check during, but I will definitely check it out afterwards. So let's go ahead and dive in here. Before we get into the material itself, a lot of the stuff that we're going to be talking about today comes from our overall DevSecOps curriculum. And specifically, the material in this class is based on some of the items that we cover in the SEC 540, the Cloud Security and DevOps Automation class. And so there's really three different topics that I want to share with you guys today. And they're all related to automation. The first one is automation related to our infrastructure security aspects. Number two is automation related to our DevSecOps pipeline. And number three is automation related to some of our application security activities. So for each of these three topics that we're going to be sharing today, I want to give you just one example from each of those three areas to basically serve as an illustration point on what we're trying to talk about there, and then do one simple basic demo for each of those three different topics: infrastructure security, DevSecOps, and application security, all in relation to automation. So to go ahead and start and dive right in, our first topic here is, of course, infrastructure security automation. And to talk a little bit about that and to make it a little bit more concrete, we're going to be talking about Cloud Custodian. Now, Cloud Custodian, some of you may be familiar with this, some of you might even use this. This is a free open source tool where there are different policies. Now, Cloud Custodian is written in Python, and you can define various Cloud Custodian policies in YAML syntax, yet another markup language. And the policies that you could define are related to, well, not only security, that we'll talk about more here in a moment, but also related to cost management. Do you have unnecessary instances up? Do you have unnecessary resources up in the cloud that are costing your organization some money that they might not normally need to pay? Well, we're going to be focusing on the security-related aspects of Cloud Custodian. And the interesting thing to note is when this was first created by Kapil Thangavula from Capital One, it originally, some years ago, only supported AWS. But over time, as it's been further developed, there's now support for Azure, and there's now alpha support for GCP, Google Cloud Platform, as well. Well, what does Cloud Custodian actually provide? From a security perspective, if you go to their website, there's a long list of things, dozens of different things that Cloud Custodian can help you do. I've taken just 5 examples of some of their policies and listed them here on the slide because these are ones that are more closely related to security automation activities. For example, detecting root logins from invalid IP addresses, blocking resources in non-standard regions. You might be a part of an organization that has decided to deploy some resources in US East 1, but you know that you are not deploying any AWS resources in AP Northeast 1, for example, in Asia Pacific. And so if you do detect that some services are stood up, utilized in some of those non-standard regions for your organization, Cloud Custodian has capability to automatically block those things. Similarly, the third bullet here, configuring ELB, Elastic Load Balancers, TLS, Transport Layer Security Ciphers. We probably all, over the course of time in our careers, encountered the situation where a certificate for your website, your HTTP, TLS, SSL certificate, has become invalid, or it's using the wrong cipher suite, using the wrong protocol that is a little bit less secure than we might actually want. Cloud Custodian has the capability to automatically check to see what the ciphers and protocols are for your various TLS certificates as well. Second to last bullet here, configuring settings to block public S3 objects. Over the last couple of years, there's been many different instances in the news of organizations inadvertently publishing data in open S3 buckets, kind of like your now modern day version of anonymous FTP, where sensitive voting records, sensitive financial information, even sensitive intelligence information has been shared on public S3 buckets. Well, Cloud Custodian has the capability to automatically configure settings and block access to some of those public object ACLs, access control lists as well. And for the purpose of this presentation here today, the thing that we're going to spend a little bit more time talking about is the last one, detecting and remediating various security group violations. Now, security group is your AWS equivalent of essentially your stateful firewall. And as you know, firewall is there to block access on certain IP addresses and different ports. Well, what if somebody inadvertently misconfigures your security group, misconfigures your firewall to have open access to anything on your network? Obviously, that is not an ideal situation. So if you've got that, one of the things that you can do here is you can go ahead and define a Cloud Custodian policy. And as we mentioned, this Cloud Custodian policy is written in YAML, yet another markup language that we see here on the screen. And in this example Cloud Custodian policy, you can see that I've highlighted 4 different things. Well, at the top, number 1, well, which policy is this? This is the high-risk security group remediate policy that specifically looks at certain events from CloudTrail. Every action, everything that you do in AWS, right, pretty for the most part, is logged in CloudTrail. And so here we are defining this Cloud Custodian policy specifically to look for a few different things related to security groups. Do we authorize security group ingress, authorize egress, revoke that egress, or revoke that corresponding ingress? And most importantly, down here at the bottom, we are saying, hey, if you detect activity for any one of those CloudTrail events, right, that is related to creating a rule for 0.0.0.0/0, allowing access to anything, anybody, right? Then if we detect that particular situation, we want to go ahead and at the very bottom here, revoke that corresponding configuration that was just put in place. So now I'm going to go ahead and switch to the browser real quick. So we just talked about security groups. We just talking about misconfiguring a security group. And as I mentioned, we've got some basic demos that I want to share with you today. So I'm switching the screen. I'm switched over to the AWS console where I am currently logged in. And I have specifically created this example, what I've called bad security group here on the screen. And you can see if I go to the inbound rules, there are no inbound rules currently defined for this particular security group. So basically nothing is allowed. Well, I'm going to go ahead and, maybe I'm a new administrator, I perhaps don't know any better, but I'm going to go ahead and add a rule to allow all TCP traffic from anywhere on the internet, right? That for any resource that might be a part of this particular security group. Once I click save, you can see that the inbound tab here has added a couple different rules. Now, again, simple demo here. Now, keep this in mind. We're going to come back to this in just a little bit. So I'm going to switch back to the slides here. And we left off looking at the example policy, the Cloud Custodian policy. So now that we've got this defined, well, what happens when you actually deploy this to your AWS environment? If you do custodian deploy this particular policy, under the covers, what happens is here on the next slide. Well, we already mentioned on the far left here, AWS CloudTrail. And as we said, AWS, things you do in AWS generate these CloudTrail logs. Well, when you deploy that Cloud Custodian policy that we just saw on the prior slide, under the covers, it creates a trigger. So CloudWatch is going to go ahead and watch the different logs that are generated by CloudTrail. And if you recall, there were those 4 different events that we looked at in terms of authorizing security group ingress, egress, and revoking those. Anytime CloudTrail has some events that are related to that, CloudWatch is going to be looking for them via that event rule. And if it detects it, it's going to initiate a target trigger. It's going to trigger a particular target. In this particular case, that Cloud Custodian policy that we saw, that remediate capability down at the bottom of the prior slide, it winds up generating an AWS Lambda function. And this Lambda function, which we'll see shortly here, is triggered to then actually remediate that particular violation and reconfigure the security group to not have 0.0.0 access that we just looked at. So let's go ahead and take a look at each one of these in a little bit more detail. When I went into the console and you saw me in that bad security group add in that access 0.0.0 from everywhere to everywhere, well, under the covers, right, CloudTrail automatically generates this particular log. And it says, this was a security group ingress operation. In the middle here, we've got the corresponding security group ID, that bad security group, the corresponding ID that was modified. And at the bottom, you can see the corresponding configuration. Now, at the very top, keep a mental note of that particular time. It was when the screenshot was taken, it was done at 4:53 and some odd milliseconds there. So it was about 4:53 when this actually occurred. Now, you've got that CloudTrail log that's generated. When you deploy that Cloud Custodian policy, well, as I mentioned, it generates under the covers, it creates for you under the covers a CloudWatch event rule. And here we see this CloudWatch event rule that got generated. And just like we saw in the YAML policy, we've got those 4 different operations down here at the bottom. This CloudWatch event rule is looking for any of those 4. And moving on to the next slide, in addition to the CloudTrail logs, you see here the CloudWatch event log. So at the very top, remember it was 4:53 and some odd milliseconds, less than a minute later in the second row from the top, you can see that this CloudWatch event log was generated, was triggered. And then a little bit further down, you can see that the event name, authorized security group ingress, the corresponding security group name that was actually updated, right? This is information that came from CloudTrail that is being sent to, that is also available in CloudWatch, the corresponding allowed IPs. But most importantly for this CloudWatch event, in the lower right-hand corner, you can see that this CloudWatch event also invokes this remove permission action to actually remediate that particular security group setting that was created. And so when the remediation trigger is called, well, this CloudWatch event target calls the corresponding Lambda function that Cloud Custodian created for us, this custodian high-risk security groups remediate, this particular Lambda function. And if you were to drill down into the details of the Lambda function itself, you would see, and this is just a screenshot from AWS Lambda in the console itself, that you've got a corresponding on line number 38, remove permission type here, that under the covers will automatically reconfigure the security group for us. So this is just an example of how we can not only detect that some misconfiguration has likely occurred, that security group change, but it's also an example to show how we can automatically, using Cloud Custodian, remediate, remove that 0.0.0, because once Cloud Custodian sees it, once Cloud Custodian detects it, it's going to go ahead and remove that 0.0.0 to make sure that we don't have open access from the internet to some of our resources. Well, you might be asking yourself, well, that's great to automatically remediate that, automatically remove that bad security group, that bad firewall rule. Well, but then isn't the administrator, the person that made that change, going to be confused? A few seconds later, it disappears. And so they're going to go ahead and go back and try to create it again, reconfigure the security group with that bad configuration. Well, down here at the bottom on line 43, now this is just an example here, but here we see test@example.com. Cloud Custodian also has functionality, if you configure it correctly, that says, hey, if you detect this particular bad activity, don't just remediate it, remove the corresponding configuration, but go ahead and send an email to the system owner and say, hey, this is what actually occurred. You did this setting, you changed the setting in the security group, we automatically removed it, and this is noticed to say, hey, please don't do that again for these particular reasons. So not only is it automating not only the detection, but the corresponding remediation of some misconfigurations, it's also, Cloud Custodian is also working to help inform and change behavior over time to make sure that people know why certain activities are taking place. So with that, I'm going to go ahead and switch back here to the AWS console that I previously showed you before. Now, it's been a little bit of time since I added this security group 0.0.0.0 rule. So I'm going to go ahead and I'm going to hit the refresh button up here in the upper right-hand corner of the screen. Now, this will go pretty fast, but once I hit refresh, right, it might take your screen a second or two to show it, but I'm going to go ahead and click refresh, and you will see down at the bottom the corresponding offending configuration will have disappeared, because under the covers, Cloud Custodian just did all of the stuff that we just talked about on the slides and got rid of that bad security group permission, that inbound rule there. Now, I think that is really cool. So this is just one example of one of the things that you can do from an infrastructure security automation perspective. So going back to the slides here, right? Let me pause for a moment. And Carol, I'm going to chime in. I'm going to ask you to chime in here. And if there are any questions that happened so far in this section, please do let me know before I go ahead and start on the next section here.
Okay, yeah, I don't see anything so far.
All right, thank you very much. So if that was number one, infrastructure security automation, let's talk a little bit about DevOps, DevSecOps, and DevSecOps related automation. And really, when we talk about DevOps, the backbone to the DevOps process is your DevOps pipeline, your DevOps CI, continuous integration, and CD, continuous delivery pipeline that helps you automate the process of building and deploying your systems, your applications to production. And when we talk about DevOps and the corresponding pipeline, we really talk about these 5 high-level phases. The activities that occur during the pre-commit phase, before you actually check in some code, your development team or security team checks in some code to your version control system, something like a Git. So before you actually do a git commit, git add, git push, right? You've got the pre-commit phase. Then you've got the commit phase, when you actually do the git push, right? And that actually checks in your code to your version control system. Once code is checked in, your continuous integration, your CI process automatically kicks off and automatically builds your corresponding application, your system overall, so that it is archived, it is packaged, and ready to be deployed to different environments, like your acceptance environment, where you can conduct some functional testing, like your other environments, like your QA, load, staging environment, and ultimately getting you to your production environment that then leads you into a phase of kind of continuous operations in terms of your monitoring, testing, auditing, and other compliance checks. So that is your overall 5 phases of the DevOps pipeline here. And we'll talk about in a moment here, how that relates to security. Now, before we do that though, here I do want to share with you really quickly here on this slide, we've got our SANS DevOps DevSecOps poster. And this poster on this particular side, the link to download this PDF version of this poster is in the lower left-hand corner of the slide. But this is divided into 3 different parts. In the upper left-hand corner, we got our Cloud Security Top 10, and this has been created and contributed to by Ben Hagan and a number of other folks. We've got our Serverless Security Top 10 in the middle left here, which was contributed by Ori Segal and a number of other folks as well. And then specifically as it relates to DevOps, we've got our Secure DevOps Toolchain on the right-hand side. Now, I know you can't make out all of that on the screen perhaps right now because there's a little bit of small font. It's much bigger in the poster itself. The PDF version that you can download will be much bigger as well. The main point here is to say, for each of the 5 phases that we just saw on the previous slide, pre-commit, commit, acceptance, production, operations, and so on, right? We've got a number of corresponding tools listed for each of these sections. Vast majority of these tools are free, open source tools that you can integrate, inject into your CI/CD DevOps pipeline to start to automate some of the different security checks as code is flowing through the pipeline itself. So with that in mind, here, going to the next slide here, we've got, okay, for each of those 5 different phases, what are the categories of our security tools and corresponding processes? Now, this is not to say that you can only do one of these particular checks in one of these particular phases, right? But it's to say, okay, well, where is this particular item perhaps most commonly done, most appropriate? For example, if we take pre-commit on the far left-hand side, in this slide, we've got threat modeling, right? So looking at the different entry points, looking at the different architecture, looking at the overall design of the system to see what an attacker might be able to do against the target application and system itself. You've got IDE security plugins on the left-hand side here as well. As your developer is coding in their IDE, their integrated development environment, just like when you are creating something, when you're writing a document in Microsoft Word and you make a spelling mistake, you make a grammatical mistake, it gives you the little squiggly line under the covers, under the word, under the phrase itself, to indicate to you, the writer, that there's probably some sort of issue. Well, the IDE security plugin, modern IDE security plugins, can do the same thing. Developer is writing some code. They make a coding mistake that will result in a vulnerability. The plugin itself can automatically detect whether that is the case, give you a little squiggly line and say, hey, here's the suggested remediation, just like Microsoft Word might actually do, but for code itself. Sticking on the left-hand side, lower left-hand corner, pre-commit hooks. We just talked about doing a git commit, doing a git push. Before the commit actually happens to your source control system, well, you might have some pre-commit hook that looks for certain things that you don't want to be checked in, like passwords, like secrets, like credentials, like certificates. And in those particular cases, you can install different tools like Git Secrets from AWS, that when a check-in occurs, when a commit is attempted, it will automatically detect, see if there's some sensitive data in it, and prevent that commit from actually occurring. Bottom left-hand corner, we've also got peer code review that can be conducted looking for different security issues. So this slide, we could probably spend hours and hours talking about this slide alone. So I'll quickly try to go through some of the other items here. In the commit phase, we've got your static code analysis, your static application security testing, your typical SAST tools that are automatically scanning your code when you check it in during the continuous integration process. Similarly, you might have some security unit tests that you might run, some dependency management checks looking for vulnerable packages. We all know that the headlines related to the Equifax breach, one of the reasons that the attackers was able to get in was because of the struts vulnerability, the vulnerability in the Apache struts library. And part of that was a, well, software supply chain issue, a dependency management issue there. You also have container security. Under the acceptance phase, you've got your dynamic application security tests, your DAST tests, looking for security issues in the running environment itself. Some corresponding acceptance tests, infrastructure as code, which we're going to talk more about in the next section, and then proper configuration management as well. Now, from a production and operations perspective, a number of other activities that we can keep in mind, but really, I want to go ahead and focus the rest of this section on infrastructure as code. So let's go ahead and talk a little bit more about infrastructure as code here. Now, just like our applications, we've got code that is created to enable the functionality of our applications. We want to do the same thing from an infrastructure perspective. Instead of perhaps using legacy system administration practices of having a Uber system administrator, knowing everything about the system and clicking next to configure and running from the command line a number of different commands to actually download different packages and stand up and build a server. What we want to do is we want to treat modern infrastructure, well, as code. Many of us have probably heard the saying that we see here towards the bottom. We want to treat our systems, our runtimes, like cattle, not pets. It used to be, especially when I earlier in my career, you would create a server, a set of servers, and you would give them love, care, and feeding, and you would take care of them, and you would give them unique different names like Apollo, Starbuck, and Husker, and so on. Well, in those particular cases, those servers, those systems, became more like pets. They became unique snowflakes that were harder to maintain because each had their own little idiosyncrasies. Now, this might seem a little bit harsh, but what we want to do is treat our servers, our systems, not like pets, but we want to treat them like cattle, standardizing across all of our systems and create environments where we can easily tear down a server if we like and easily stand it back up. So this concept of a phoenix server, if you will, in terms of rising from the ashes. So we remind ourselves here of infrastructure as code because this is also related to the concept of blue-green deployment. Now, blue-green deployment, this is a concept that has been around for a long time. This is not really anything new, right? The idea being that you've got a live production environment that you might call conceptually your blue environment. Well, you've got some fix, a patch, an application bug, vulnerability that you might want to fix. Well, then you might deploy that particular fix, not in production, but in your green non-production environment. And then once you test to confirm that the blue environment, production environment, to the green environment, which then becomes your production environment. And so these colors could be anything, but the standard way to refer to them is blue-green. And the benefits of this is that you can, well, now deploy fixes, deploy not only new functionality, but deploy new security fixes with essentially zero downtime. Now, let me ask a rhetorical question. How long does it take a developer to fix a basic SQL injection vulnerability in an application? Now, typically it's minutes, 10 minutes, 15 minutes, 30 minutes. Now that same quick to code fix, important security fix, environments to production itself. Now, some of you might be thinking in your minds, well, yes, it could be quick. I've seen organizations take weeks, sometimes months, to deploy that seemingly trivial fix. Why? Well, because there are different management approvals, reviews, deploying it into different environments along the way before it gets to production, different operational reviews, CAB, change advisory board review, and so on. And so this concept of blue-green deployment, not only from the process perspective, even though it's been around for a long time, hasn't traditionally been as widely used as perhaps we would have liked. Why not? Well, because it's expensive. In traditional environments, it was expensive to do because in addition to your production infrastructure, you also had to have an equivalent or like infrastructure that was your green environment, so that when something happened, you would be able to deploy to that production-like environment, your green environment. Well, now, fast forward to today with modern cloud infrastructures, with this concept of immutable infrastructure, cattle not pets, right? A well-defined environment boundary, we can automate the changes to both our blue and our green environments. Well, what does this actually look like? This is just an example, right, of using AWS's ECS, Elastic Container Service, to be able to stand up two different ECS services, a blue production one, a green one with some updates. And in this particular case, right, we can see that the blast radius in terms of the scope of any changes, the load balancer that we see at the top of this diagram, that's not included in the blast radius, right? The blast radius in this particular case is really limited to the ECS service itself. And because of our automation, our automated capabilities, we can stand up and update both of these environments simultaneously. From a code perspective, what does this actually look like? Well, it's very simple. On the left-hand side, we've got our existing production environment. And in this example, and I'll show you a basic demo here in just a moment, in this example, we've got production environment running on port 443, running with SSL. Well, in our green environment that we want to stand up to test our changes, we have it running on port 4444 in this particular case. And so this is a simple, basic example of using infrastructure as code. We can automate the things that get deployed via our DevOps pipeline. So keep that concept in mind, because I'm going to go ahead and switch now to a VM, a virtual machine that I have running. Let me go ahead and unlock the screen. And we've got a fictional application here, the Dunder Mifflin application. And I'm going to go ahead and log in the upper right-hand corner, click the login button. And I'm going to go ahead and log in here as the P. Beasley user. This is Pam's user ID. And once I sign in, there is some functionality. And on the right-hand side, we've got this My Profile functionality, which, as the name implies, allows the logged in person, in this particular case, Pam, to see the details of her particular account and all of her personal information. Well, it turns out that this portion of the application is vulnerable to parameter manipulation that causes an access control vulnerability. So this is your classic case of parameter manipulation, where all I have to do is go up to the URL bar, and I'm going to go ahead and add another parameter. I'm going to change the parameter, add one to say ID = 1. And once I hit enter, you're going to see that on the screen, instead of Pam's information displaying in the middle left here, I'm going to hit enter, and you can see that it changes to somebody else's information. In this particular case, it changes to Michael Scott's information. I'm going to go ahead and go back to the URL bar and change it to ID = not 1, but to 2, and hit enter. And you can see now we have Jim's information displaying, somebody else's information, your classic access control bypass, right? You're getting information, access to information that you shouldn't have using parameter manipulation here. Now that's obviously bad, and we don't want to wait, right, weeks, months, perhaps for this fix to get deployed, because we got an information disclosure risk here. So I'm going to go to this next tab, and this next tab, just like we discussed in the slides, this is the same version of the app, but it has been updated to patch that particular vulnerability. And in this case, we've got the app, as we said on the slides, running on port 444 for demonstration purposes. So I'm going to go ahead and log in. And again, I'm going to go ahead and log in using the Pam, P. Beasley user, sign in with her password. Once I signed in, I'm again on the right-hand side, going to go to the My Profile functionality. And My Profile here, you can see, yes, we are seeing the logged in user's information. But now, in the URL bar, I'm going to go ahead and try that parameter manipulation again, entering ID equals 1. And once I hit enter, right, you can see on the screen, instead of seeing Michael's information, we still see Pam's information, because under the covers, we have deployed the corresponding fix for the vulnerability. And if I try the same thing, ID equals 2 in the URL bar, hit return again, right, you will be able to see that, yes, we do not have that information disclosure because of that parameter manipulation vulnerability. So just an example showing how in one tab, we are referencing the blue environment, the other tab, we are referencing the green environment, letting us essentially have zero downtime, virtually zero downtime deploys. And that is, if I switch back to the slides here, and one of the biggest benefits that DevOps and this corresponding automation in this pipeline gives us is that it allows us to deploy security fixes, security patches, fixes to security vulnerabilities in a quicker, faster, more repeatable and automated fashion. So before I go on to the next section, I'm going to go ahead and ask Carol again if there's any other questions or comments that have come up in the chat window here.
All right, Frank, yes, we've had one. It says, do you have to write the Cloud Custodian code on the CloudWatch, or it comes as a separate tool?
Great question. So you do not have to write the Cloud Custodian underlying code for the Lambda function or the CloudWatch event. At the very beginning, I showed that Cloud Custodian policy. Now, there's a number of Cloud Custodian policies. If you go to their website, that out of the box, you can get those Cloud Custodian policies in YAML. You do have to make some tweaks to that to configure it, to add the appropriate email address, as I mentioned, and some other configuration options. But all of that code is written for you. Once you deploy that Cloud Custodian policy under the covers, Cloud Custodian using the AWS API, and Cloud Custodian is written in Python. I might have forgotten to mention that before. Under the covers, the Python code will call various AWS SDK, AWS services via the SDK, and it will create for you those things that we talked about in this section. So the CloudWatch event, the corresponding Lambda function, and so on. So there's not you don't necessarily have to code it yourself, although there are some tweaks and configurations that you're going to likely have to make. Good question. Good question.
All right, and that's the only one, Frank.
All right. Thank you very much. So moving on to the last section here is application security automation. And for this section, I really only want to talk about one thing to serve as an example for mitigating, blocking application security vulnerabilities. And specifically, we're going to be taking a look at the AWS WAF, the AWS Web Application Firewall. Now, a Web Application Firewall is something that looks at all of your HTTP, HTTPS traffic, looking for common application vulnerabilities, signs of application attacks like cross-site scripting, like SQL injection, and certain WAFs can also look for anomalous activity. Now, your typical WAF, when you buy it, a commercial WAF, when you buy it from any number of the vendors that might be out there on the marketplace, they usually come with a set of rules to look for those things like cross-site scripting, like SQL injection. The AWS WAF, if you log into your AWS console, go to aws.com, amazon.com, it's a little bit funny, right? It doesn't do anything out of the box by default. There are no rules that are automatically created. So what AWS has done is they've created what they call this AWS WAF Security Automations project. Now, this is a free set of code that is available in their GitHub repository that has a number of different rules that you can install, you can configure in your AWS WAF for some common security functionality, like blocking some of those OWASP top 10 type of vulnerabilities that we just mentioned, like looking for automated scanning activity, like that come from bad bots that might be continuously scanning your website, like preventing access from known bad IP addresses. We know that there are certain IP addresses that are, well, maybe compromised systems. Attackers are using them to conduct malicious activity. Based on that list of known bad IP addresses, you can go ahead and automatically update your WAF to block traffic from those particular IPs. So that's a quick overview of the WAF Security Automations project. Well, what does it look like from a visual perspective? Well, the AWS WAF can be associated with traffic that is on the left-hand side of this diagram coming from your either application load balancer or your CloudFront distribution. Now, in the middle, the AWS WAF has some of that functionality that we were talking about. The interesting thing to point out here from an automation perspective is that some of these particular rules, like the bad bot and scraper protection here, it uses on the right-hand side here an AWS Lambda function. And the Lambda function automatically keeps track of, well, activity to a certain API gateway endpoint, automatically keeps track of, well, the logs that are saved in your S3 log bucket. So who is actually accessing your website? And if there is repeated bad activity based on those logs, the Lambda function will then automatically reconfigure the WAF to block that particular IP address. Similarly, in the lower right-hand corner, there's another Lambda function here that says, we saw a CloudWatch event associated with Cloud Custodian earlier. This particular Lambda function, right, will go ahead and based on trigger, look for retrieve data from third-party IP reputation lists, and using that set of bad IP addresses, update the WAF, if you so choose, from any feed that you actually like to block IP addresses against your application from those known bad IPs. So some pretty cool functionality here. So from an automation perspective, right, we talked about infrastructure as code. How do we actually go about enabling this? Well, this is just an example of the CloudFormation code that you can use to enable the WAF in your environment. Again, this is a slightly modified version of the stuff that they have on the AWS GitHub repository. And I've used this to point out that at the bottom here, you've got SQL injection protection, cross-site scripting protection. You can toggle these on or off, right, depending on whether or not you actually want to enable them. But you don't necessarily just want somebody to sit there and be deploying this code. And so what we want to think about is combining, marrying, right, what we talked about in the DevOps pipeline to automate not only the deployment of our applications, our security fixes, patches to application vulnerabilities, we also want to go ahead and utilize those DevOps practices to automate the deployment and updates to our infrastructure as well. Now, normally, if you wanted to deploy your AWS WAF, you would get the corresponding CloudFormation code, and you would call from the command line something like AWS CloudFormation deploy, specifically with the -- stack name, whatever name you're giving it, pointing to the -- template file that contains the corresponding code that you want to deploy. Well, instead of doing that just from the command line, this is a screenshot with Jenkins, the new Jenkins Blue Ocean interface that says, hey, for some of these different steps in your automated deployment pipeline, in the deploy step, under the covers, the deploy phase is basically going to call this AWS CloudFormation command, deploy, in this particular example, your AWS WAF, so that now your app can automatically be protected from an application perspective by some of this WAF functionality as well, but really showing how we can marry some of these concepts to not only deploy automatically our application changes, but our infrastructure changes as well. Now, with that in mind, I'm going to go ahead and switch to our last simple demo that I was telling you earlier about. So I'm going to go ahead and switch back to the VM, unlock my screen again. And it turns out that in this Dunder Mifflin application, I'm going to go ahead and sign in again as the Pam P. Beasley user. And when I sign in, and I went to the advanced search functionality, this advanced search functionality, it turns out, is vulnerable to cross-site scripting. And so here in the submitted by field, we've got your standard way of checking for the presence of cross-site scripting, your script alert message, XSS, closing script tag. And of course, to refresh our memory here, cross-site scripting occurs when you've got some, well, unvalidated, malicious data that is submitted up to your application, submitted up to your server, and that unvalidated data then gets sent back down to the browser. And so here, we're going to be doing exactly the same thing, where I click this search button, this data gets sent up to the Dunder Mifflin application running on the server side. The application sends it back down in the browser response. When the browser sees it, it says, I've got some data, some commands, usually in the form of JavaScript and HTML, and the server, right, the application is telling me, the browser, what to do. And in this case, it thinks that the server is telling the browser to pop up an alert box. So now, when I click search, you're going to see that the data gets sent up to the server, sent back down to the browser sees that script alert script, and it says, the server's telling me to pop up an alert box, which is what it does here in terms of showing you this alert box with the message XSS. And this is just our standard typical way to test for the presence of cross-site scripting, right? So here, just reminding ourselves what cross-site scripting is. Well, under the covers, I've already deployed the WAF, but I haven't turned it on yet for demonstration purposes. And so what we want to do is we want to go ahead and enable the WAF. And to do that, I'm going to go ahead and just copy this command here. And we are just from the AWS command line, calling AWS WAF regional associate the web ACL. So the WAF web ACL specifically needs to be associated with the ALB, the application load balancer for this application that we were just looking at in the browser. So now to enable the WAF, I'm going to go ahead and switch to the terminal, and I'm just going to go ahead and execute that particular command. It takes just a moment for that to run. So now that that has completed, I'm going to go back to the browser, go back to the advanced search page, and try to re-add that same script alert script. And once I click search, instead of the data still gets sent up to the server, attempts to be echoed back down. But once I click search, the data gets sent up to the server in this case. The WAF sees it first and says, there's some malicious data in here. So I'm going to go ahead and block that data from even getting to the application and send back to the browser, to the user, the 403 forbidden message in this particular case. And just to emphasize that, I'm going to go ahead and now turn off the WAF using this command here. And all we have to do is call AWS WAF disassociate the web ACL from the corresponding ALB application load balancer. So now when I go back to the terminal, put in this command, hit enter, takes just a moment for it to run. Now when I go back to the browser and try to enter that search field again, script alert script, clicking search, you can see the data gets sent up to the app, comes back down to the browser in this case because it wasn't blocked, and we've confirmed, yes, the WAF is now no longer enabled in this particular case. So if I go back to the slides, just to summarize, what are the things that we have talked about up to this point? Really three things. Automation, as it relates to our infrastructure security checks. Specifically, we looked at Cloud Custodian, how it can automate the removal of that security group misconfiguration. Automation related to our DevSecOps pipeline, the 5 different phases of our CI/CD pipeline. And then automation related to some application security issues, specifically using infrastructure as code to automate the deployment of our WAF and the corresponding blocking associated with that. And so just kind of in summary here, at the beginning of this session, I mentioned that the material here is based on the SEC 540 class. We've been making some changes to the class. And here, not only do we have some changes related to the title, specifically the class is called Cloud Security and DevOps Automation. We also have every day from days 1 to 4 of the class some NetWars bonus challenges. And day 5 also has a NetWars capstone exercise as well. The winner, the top scorers of the bonus challenges actually get a coin. And the coin, as we see here on the right-hand side, we're pretty excited about this. We think it looks pretty cool. On the top right here, we've got the SEC and the clouds, right? Of course, representing cloud security. We have the 540 in these little boxes, packages, if you will, representing containers, Docker containers. We're moving along on the conveyor belt here, right? And this conveyor belt is intended to represent our DevOps pipeline that we talked about, our whole CI/CD pipeline. And of course, on the other side of the coin, we've got a unicorn. It turns out that a unicorn, the companies, the internet companies like Amazon and Etsy and Twitter and Google and so on, that have kind of pioneered some leading DevOps practices, well, those organizations are referred to as unicorns. On the flip side, if you got a large enterprise, financial institution, healthcare, and other, right, some of those organizations that have pioneered, some of those traditional enterprises that have pioneered DevOps practices, they're referred to as horses, right, which is why we've got this horse/unicorn on this other side of the coin. And on the main, one last thing I'll mention, on the main of the horse, right, that's actually all binary, zeros and ones, that actually decodes, decodes into just the number 540, right, the course number itself. But what else is new with this class? We've also introduced some additional Azure content where you can deploy, well, that Dunder Mifflin application that we looked at into Azure using Terraform, Kubernetes, and their version of blue-green. And in addition to not the winners of the challenges, not only getting the coin, but everybody who attends will also receive a 540 sticker associated with the class as well. So a couple other things I want to mention. We also have coming up later in the year in November, our Cloud and DevOps Security Summit. This is happening in Denver. The summit is November 4th and 5th, corresponding training in the week following. And just to go ahead and wrap it up, and I'm going to turn it over to Carol to see if there's any questions here as well. This webcast is part of a set of webcasts related to our DevSecOps curriculum. Eric Johnson has already done one called Keys for Modern DevSecOps Success. David Hazar is going to be doing a webcast on Azure Information Infrastructure Automation. And Mark Easlin is going to be doing one on cloud data protection as well. So thank you all for coming. Let me go ahead and pause and see if there's any questions. Hey, Carol, I'm not sure if you're on mute.
Yeah, sorry, Frank. Yes, we do have a question that's come in. They ask, which certification can the SEC 540 course lead to?
Yeah, great question. Currently, there is no certification for this specific class. That is something that we are actually working on. Hopefully we're going to be able to get that certification out sometime next year or so. But that is something that the GIAC team and that we've been thinking about, we've been talking about, and that is definitely kind of top of the list here.
All right, that's all the questions I see. Do you have any closing thoughts you'd like to share?
No, thank you everybody for attending, and yeah, hopefully you can move a little bit further along in your security automation journey. Thanks a lot, everyone.
All right, well, thank you so much, Frank, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.